Hello and welcome to our, walkthrough, our practice, in-class practice for 8-1, the altitude on hypotenuse theorems. If you watched the video, you know that we walked through the similar triangles of a right triangle within a right triangle, and 3 equations are developed, and I will highlight them right here. So these 3 equations are developed and they create the altitude on hypotenuse theorems, where we should label, let's say we have a right triangle here, and the most important thing to label is the hypotenuse. In this case, the hypotenuse is AB, so the whole length hypotenuse. Then we also have leg 1, we have leg 2, and then we have parts. So we could say this is part 1, AD, part 2, DB, and then we also have this line that goes from the vertex to the base and is perpendicular to the base, and we call that the altitude. And I'm just gonna write alt for shorthand, and let's just do a little bit of a hypotenuse thing here. So just labeling it out, and then we have our 3 equations. The leg 1 squared is equal to the part times the hypotenuse. Okay, we also have, maybe easier with the highlighter, leg 2 squared is equal to the part 2 times the entire hypotenuse. And then lastly, we have the altitude squared is equal to part 1 times part 2. So those 3 equations are going to be used exclusively in today's lesson, along with possibly the Pythagorean theorem. So let's take a look at these first 2 problems. It says, find x, y, and z, leave answered as simplified radicals. So leave answers as simplified radicals. So let's take a look. In this particular equation, we see our big right angle or right triangle, and we are given parts, and we could actually calculate the hypotenuse, which is 7. So we could, if you want to, we could call this leg 1, leg 2, part 1, and part 2. Okay, and in this, let's actually rewrite the equations so we could see them again. Leg 1 quantity squared, or leg 1 squared is equal to part 1 times hypotenuse. Leg 2 squared is equal to part 2 times the hypotenuse. And then lastly, we have altitude squared is equal to part 1 times part 2. So in this particular case, we could solve for, if we wanted to, we could probably just solve for the altitude right away because we have both parts, part 1 and part 2. So let's do it. Altitude is x squared is equal to part 1, which is 2, times part 2, which is 5. Then we just get x squared is equal to 10, square root both sides, and you can't simplify this anymore, so we leave this as x is equal to the square root of 10. Simple and straightforward, okay? Now let's look at y. Y is the leg 1. And we actually have part 1 and we have the hypotenuse. So we could use that equation. So let's do it. So we could say y squared is equal to part 1 times the hypotenuse. So we get y squared is equal to 14, square root both sides, and y is then equal to just square root 14 because that does not simplify any further. Last one is z, and if we see what z is L2. We have the part, we have the hypotenuse, and we could actually just proceed as follows. Z squared is equal to part 2 times the hypotenuse. We get z squared is equal to 35, root both sides, and we get z is equal to root 35. It doesn't break down, we keep it as it is. Okay, so pretty easy. pretty straightforward problem. And let's move on to number 2. I'm going to move this down here. Let's shrink this a little bit. And let's see what we get. This time around, we're solving for x, y, and z, but let's actually skip this one because this one actually completely reflects number 1. Okay, well, let's just do, for instance, let's just do the altitude, I guess, really quickly. Now, we know the hypotenuse here is 9. We actually don't need that. Part 1 times part 2. So, altitude, let's solve for z. So, just a quick problem. So, the altitude we're solving for, z squared is equal to part 1 times part 2. We get z squared is equal to 8, square root both sides, and this one actually can be simplified. This would break down to root 4 and root 2. And z would be equal to 2 root 2. Now, remember, we would technically have negative plus minus in front of this, but we don't take negative lengths in geometry, so we kind of just wash that away. So, the altitude is equal to 2 root 2 in this particular sense. Looking at number 3, this one is particularly interesting for a couple reasons. So let's break this down. We have a leg, because we identify our hypotenuse first. This is our hypotenuse. We have leg 1. We also have leg 2. And that's all. And if you look closely, all of our equations require the part or the hypotenuse. So all of these equations actually we can't use unless we realize this is a right triangle. And we could use the Pythagorean theorem to solve for that hypotenuse. So we could use our a squared plus b squared is equal to c squared, or in this case, leg 1 squared times plus leg 2 squared is equal to the hypotenuse. So we'll do 6 squared plus 8 squared is equal to the c squared. And if you remember our Pythagorean triples, we could, if you recognize it, you could say that c is equal to 10. Now, if you did not recognize it, you could always just do this long way. And we realize this is equal to 100 is equal to c squared, square root both sides. And you get c is equal to 10. So 6, 8, 10 is a multiple of that 3, 4, 5 Pythagorean triple. Okay, so I'm going to shift this over just a little bit. We now know that the hypotenuse here is equal to 10. And with that said, we could actually use this to solve for part 1 and part 2. So let's take a look. Let's solve for, let's say, part 1 first. So we'll take L1, which is 6 squared, is equal to part 1. In this case, part 1 is x. So let's label this part 1, part 2. So let's erase that. We get x times the hypotenuse, 10. Okay. We get 6 squared, which is 36, is equal to 10x. Divide both sides by 10, and I would definitely leave these in fraction form, just reduce them. So we should get x is equal to 18 over 5. Now, we could do one of two things here. We know that now that this part 1 is equal to 18 over 5. We could always find the difference between 10 and 18 over 5 to calculate what the other part is. That would be the faster way, but if we also notice, we're working with fractions, and that can be a little bit of a mess. So in this particular case, it actually might be easier to just use a formula. So if we wanted to, for instance, solve for part 2, we might actually just consider using that second equation. So let's do it. Leg 2 is equal to 8, so this is 8 squared, is equal to part 2 part 2, which is y times 10. And then we get 64 is equal to 10y. Divide both sides by 10. And we should get, this is 32. Now let's do this. Y is equal to 32 over 5. And if you're wondering, these two do in fact add up to 10. They would add up to 50 over 5, which is equal to our 10. So either way you do this, it's really up to you. These are both valid ways to solve for part 1 and part 2. Okay, last one, solving for the altitude. Now that we have part 1 and part 2, we could actually calculate what the altitude is using that last formula. So let's take a look. We should have altitude squared, which is z squared, is equal to part 1, 18 over 5, times part 2, 32 over 5. And I'm going to need a little bit of help from our calculator. So let's clear this out. We get 18 times 32. So we get 576. And then 5 times 5 in the denominator is 25, is equal to z squared. Square root both sides. And the square root of 576, so we'll do this, is 24. So we should get z is equal to 24 over 5, because the square root of 25 is 5. And this is what our altitude is equal to. Now, you can technically do this particular problem with decimals. This would be 3.6, and this should be 6.4, which would also give us here 4.8, but I do not recommend doing that. I would keep this in fraction form, okay? Now, I would definitely say try the next few out on your own, and then pause the video, give it a shot, and then I will actually do number 6, okay? So give those a shot, and then let's see how you do for number 6. All right, so our equations. Well, we definitely have leg 1. We don't have leg 2. We have the hypotenuse. Hypotenuse is equal to 8. And we don't have either part. So we could say this is part 1, this is part 2, this is the altitude, and we actually don't even need part 2. So if you notice, there's no variable here that we actually need to solve for. So first thing I notice is we actually have the hypotenuse and we have one of the legs. We could actually solve for this other leg. So let's do it. If you do actually even notice something even more, actually you might not notice this. This looks like it could be a 30, 60, 90, where we have b, b root 3, and 2b. And this definitely looks like a 30, 60, 90 triangle to me, but let's double check to make sure. Okay, so we should have, let's call this A, B, and C. So Pythagorean theorem, we could use the Pythagorean theorem because we have one of the legs in the hypotenuse. So we'll do a squared plus 4 root 3 squared is equal to 8 squared. Okay, then we could expand this. We could say 4 root 3 times 4 root 3, which is equal to 16 root 9, which is then equal to 16 times 3, which is equal to 48. Bring everything else down. Right side is equal to 64. Subtract 48 from both sides. We should get a squared is equal to 16, square root 16, and a is then equal to 4. And ironically enough, this does fit our criteria for a 30, 60, 90. Our b value is 4. Our 2b, which is our hypotenuse, is 8, which is double that. And then our leg, it's our 60-degree side, opposite of the 60 degrees, is leg root 3. And it completely works out. So this is a 30, 60, 90 triangle, if you were wondering. But that's fine. It's neither here nor there in this particular problem that we need to do it. We don't have to memorize it for this particular problem. It's just nice if you do. So let's continue. Let's look for our part 1. Now that we have, actually we could have even done this without solving for leg 2. We didn't need it, but we'll go ahead and start solving for part 1 here. Part 1 is equal to, oops, it's not part 1, sorry, leg 1, so 4 root 3 squared is equal to part 1, which is x, times the hypotenuse 8. And we've already done this math. We already know that this should be equal to 48 is equal to 8x, divide both sides by 8, and x should be equal to 6. Okay. Now, we actually do need to solve for part 2. I was wrong earlier. In order to solve for the altitude here, we actually do need, actually, I take that back. We could use the Pythagorean theorem to solve for that last piece. The altitude actually is part of a right triangle. So if we wanted to, we could actually avoid that altogether. We don't need to solve for part 2. And we could use that. Let's highlight this in blue. We could use this blue triangle as its own right triangle. And we could say part 1, or the x, is a. So we could say 6 squared plus b squared, or y squared in this case, because that's our altitude. Y squared is equal to 4 root 3 quantity squared. So 6 squared, once again, is 30. Once again, is 36. Y squared is just y squared. And we know that this is 48 because we've done it twice now. Subtract 36. We get y squared is equal to 12. Square root both sides. This breaks down to root 4 root 3. And we should get y is equal to 2 root 3. So there's our altitude. Okay? Hopefully you got these answers. If you do have any questions about any of this, please ask. And make sure you get that geometric maze done. Other than that, have a good one, and I'll see you in the next one. Bye.